9th Standard ICSE Chemistry Chapter 2B, Types of Chemical Change or Chemical Reactions. We have four main types. Type number 1, direct combination or synthesis. Here, in a reaction, in an equation, we shall always have two reactants and one product. So it could be two elements combining to form a single compound. That's carbon plus oxygen giving carbon dioxide. By the way, it's exothermic reaction. This is also called a synthesis reaction. But we can also have an element and a compound combining to form a new compound, like this one. So this is not a synthesis reaction, it's just direct combination. We have lots of equations in this chapter which have to be learnt. Whenever we write an equation in exam, it has to be balanced. But the extra information like the states of matter or the name or the color is not necessary. In cases where it is necessary, I'll let you know. However, conditions like heat sign, catalyst, pressure, temperature, conc, these things are important, even vapors, but not gas, and precipitate. Another example, sulfur dioxide plus oxygen gives sulfur trioxide. Next, how about an example of two or more compounds combining to form a single product, that is a single compound? Ammonia plus HCl. So here two gases are combining to form a single solid. By the way, it's a sublimatory solid, ammonium chloride. It's a reversible reaction. Also, notice how quicklime, when added to water, gives you slake lime. Calcium hydroxide is partially soluble in water, and when dissolved in water, it is called lime water, which turns milky when carbon dioxide is passed through it. This reaction is exothermic. Pink box cancelled, photosynthesis cancelled. Some more experiments. When lead sulfide is reacted with oxygen, lead sulfate is formed. Notice that lead sulfide is black, whereas lead sulfate is white. These colors have to be remembered because in exam they can ask questions based on that. If they ask you observation, you would say a black reactant was converted to a white residue. Now mark this as read, which means it's not very important. It won't be asked in my test. However, I cannot cancel it because the school teacher may or may not keep it in your syllabus, so check it with your school teacher. Another experiment. Here, when you burn magnesium in air, you get a dazzling white light. Observations are important from exam point of view. Next type is decomposition reaction. This is the definition, in which a single reactant decomposes to form two or more products. Now, if it is brought about by heat, it is called thermal decomposition. For example, mercuric oxide decomposes to give mercury plus oxygen. What are the observations here? A silvery metal is seen and a gas is released which rekindles a glowing splinter. Now, these observations are not mentioned here, so it may not come in the test for this chapter, but it is there in your overall syllabus of entire chemistry, so it's there in future chapters. So I will be giving you a lot of information, keeping in mind the future chapters as well. So heat sign is required, so it's an endothermic reaction. Heat is absorbed. In exothermic, heat is given out. Next, silver chloride. In the presence of sunlight, that is, it's a photochemical reaction or photochemical decomposition, it gives a silvery metal again, and greenish yellow gas is released. By the way, greenish yellow gas doesn't necessarily mean chlorine. If you had to give a chemical test, which we'll study in practical chemistry, it would be greenish yellow gas turns moist starch, iodide paper, silvery black. What about a decomposition reaction brought about by electric current? You take acidylated water, because pure water is a bad conductor of electricity, add a few drops of acid. It will decompose into hydrogen gas and oxygen gas. Hydrogen observation is it burns with a blue flame and a pop sound is produced. Some more examples in which a compound is decomposed into another compound and an element. Because here both the products were elements. So potassium nitrate, when heated, forms potassium nitrite plus oxygen gas. More examples. At 1000 degrees Celsius, calcium carbonate decomposes to form calcium oxide plus carbon dioxide gas. Experiment number 2 is cancelled. This is a definition of thermal decomposition. Remember that these are not reversible. They are irreversible. If any such decomposition reaction is reversible, we don't call it just decomposition. We have a special name. It's called dissociation, which will come later in the chapter. Now, let's study about metallic hydroxides and their decomposition. So when you heat potassium or sodium hydroxide, that doesn't decompose. You see in the activity series, these are very reactive metals on top. So their bonds are strong, so they won't decompose on heating. There is an easy way to remember the activity series. There are many easy ways. The method I employ is remembering a sentence. Kit Kat nahi, Cadbury mango Aladdin. Zindagi fir bhi problematic hai. H stands for hydrogen here. Colgate hatao or apnao Pepsodent. So silver, after silver, gold and platinum is missing out here because they don't form hydroxides. They are non-reactive. If you look at the bottom two elements or metals in this, that is mercury and silver out here, their hydroxides, they have a weak bond and it's quite unstable. If you heat it, they just decompose into pure metal, oxygen plus water. Heat sign is compulsory in all these equations. That brings us to the elements from calcium to copper. Their hydroxides will decompose on heating to form the respective oxides and water, actually steam. Now, you don't have to learn so many equations, you just have to remember the logic behind it. Then you can frame the equation on the spot. Of course, you will need the knowledge of valency and crisscrossing to create perfect formulae, and don't forget to balance the equations in the end. Some observations here. Zinc oxide is yellow when hot and white when cold. Lead oxide is reddish yellow or buff yellow when hot and yellow when cold. Aluminium oxide is white when hot and white when cold. These three oxides are very special because in the future you will realize that these three oxides are amphoteric. That means they don't just react with acids but also with conc alkalis. So more about it in the future. Another observation, copper oxide is black in color. Silver is obviously silvery in appearance. In oxygen's test, we know that. Water vapor, there's a test for that also in practical chemistry. It turns white anhydrous copper sulphate into blue crystals. It's called blue vitriol. That's something to do with water of crystallization, which again you'll study in a future chapter called water. Now let's talk about carbonates. Again, the top two metals, they don't decompose, whereas the bottom two decompose completely to give pure metal as well. But calcium to copper, they decompose to form respective oxides and carbon dioxide gas is released. So what's the test for carbon dioxide gas? It turns lime water milky, but that's not enough evidence. In a future chapter, you'll study that even sulfur dioxide turns lime water milky. So how can we be sure it's carbon dioxide? Well, after it turns lime water milky, we test it with acidified potassium dichromate solution. If there is no change in color, then it's CO2. Or if you can even use acidified potassium permanganate solution. If there is no change in color, it is CO2. Because if it was SO2, then if you pass it through acidified potassium permanganate solution, it turns from pink to clear colorless. And if you pass it through acidified potassium dichromate solution, it turns from orange to clear green. Well, all of this is a part of chapter number 9, practical chemistry, but I just want you to be aware of these things because you need to realize that very tricky and complex questions will be asked in school tests. Application-based questions for which knowledge of observations will be useful, and practicing the exercise is a good training. Now, metal bicarbonates are a bit different because now I see that even sodium and potassium bicarbonates will decompose to form the respective carbonates, and water and carbon dioxide are also released. Nitrates, well, even here, even potassium and sodium nitrates do decompose, but they form nitrites plus oxygen. They don't form nitrogen dioxide. Whereas from calcium to copper, apart from the respective oxides, not nitrites, nitrogen dioxide is also produced, and as well as oxygen gas. The bottom two ones, they decompose completely as usual to form pure metal, and the two gases are released. Now, we know the observation for oxygen, but what's for NO2? That's reddish brown vapors, but that's not enough because even bromine vapors are reddish brown. So let me give you a test for nitrogen dioxide from practical chemistry. It turns acidified ferrous sulfate from green to brown. There are some other tests also, but as of now, keep one in mind. This big box is cancelled. Lead nitrate, that's a very important equation. Learn the formulae, balancing equation should be done. Up arrows are not required because we know that they are gases. Up arrow is required only for vapors like HCl or steam, which are not necessarily in the vapor state. For example, if you just write HCl in some equation, it might mean hydrochloric acid. Here, what are the observations? Well, a residue is formed which is reddish yellow when hot and yellow when cold. Nitrogen dioxide, I told you, reddish brown gas which turns green acidified ferrous sulfate solution brown. For this chapter, if you just write reddish brown gas, that's enough. Oxygen, it rekindles a glowing splinter. Let me tell you one more observation here. It produces a crackling sound, a decrepitation sound. So So please write that here. Now, the next equation, when you heat zinc carbonate, it decomposes to zinc oxide and carbon dioxide, and we know the observation of both. Next, ammonium dichromate, something very unique. Ammonium dichromate is an orange colored compound. Remember the colors, because in exam they will ask questions like an orange colored compound A decomposes to give a green residue B. Identify A and B. So we should know which reaction they are talking about. So chromium oxide is green in color and it gives water vapor and nitrogen gas. One more observation, flashes of light are released. Next, copper sulphate pentahydrate. Notice this dot out here, that's a weak chemical bond. It simply means that 5 molecules of water are loosely attached to the copper sulphate molecule. So the anhydrous salt has now been hydrated, means with water, and it is now in crystalline form. It is now blue in color, so it's called blue vitriol as well. But when you heat it, the bond is broken and the water evaporates. So what you get is anhydrous salt, that is without water, and now it is white in color and it is amorphous as well, that is powdery, not crystalline. So these are the observations. The reverse reaction is also possible. If you add water to this white copper sulphate salt, you will get blue vitriol. So that's a nice way to prove if some liquid is water or not. So reversible reaction is defined like this. When the conditions are reversed, you get back the reactants. Another reversible reaction is this one. When you react iron with steam. Yeah, writing steam is compulsory because water won't work for this reaction. And even iron should be red hot. Heat sign, triferric tetroxide plus hydrogen gas is released. Now, if a reaction is reversible and brought about by heat, it's called thermal dissociation. If it was irreversible, it would be called thermal decomposition. So remember this equation. So again, solid gives gas and gas. The second example, mark it as read, not very important, but learn it for school exam if teacher insists. Displacement reaction. Here we have two reactants and two products. So the more reactive element displaces the less reactive element, like this. Sulphate was happy with copper, but when she saw zinc, she dumped copper and went with zinc because zinc is better. How do we know if somebody is better? Well, look at the activity series. Clearly zinc is higher in the rank than copper. Mentioning aqueous is compulsory because the reaction will not happen in solid state. One observation I can say is that copper sulphate was initially blue solution, but in the end it became a colorless solution because zinc sulphate is white in color. Another observation, reddish brown particles or residue at the bottom of the beaker. So these observations have to be learned, not just the equations. Another example, when you add any acid to an active metal, hydrogen gas is released, which burns with a pop sound. Salt is also produced. Third one, mark it as read, not very important. So learn the activity series, and even for the halogens, learn them. Next, double decomposition reaction. That's an exchange offer here. Here we have two reactants and two products again, but both are compounds and new compounds. They have exchanged their radicals. So barium goes with sulfate and sodium goes with chlorine. This is just to add some variety in life. So again, this is of two types, precipitation and neutralization. In this reaction, you can notice that one of the products, barium sulfate, is insoluble in water, and such insoluble salts are called precipitates. It's white in color. That's quite significant because in future you will study that adding barium chloride is a good way to test if the salt is a sulfate. If you take any sulfate, sodium sulfate, potassium sulfate, or even sulfuric acid, because even that has H2SO4, and if you add barium chloride, you will get a white PPT proving that it is sulfuric acid or a sulfate. Now another reaction, hydrogen sulfide reacts with copper sulfate to form a black PPT, which is copper sulfide. So we have only two black PPTs in our syllabus, copper oxide and copper sulfide. We also have manganese dioxide as black. So as soon as you read something about black, this should strike you. Next reaction is whenever you add silver nitrate to hydrochloric acid, or any chloride for that matter, you will get a white PPT, silver chloride. So that's a nice way to prove that the acid is hydrochloric acid. But in 10th standard, you will study some extra points, that the white PPT should be insoluble in nitric acid, but soluble in excess of ammonium hydroxide. Next reaction, it's a repetition. If you add barium chloride to sulfuric acid, you get a white PPT. Sometimes a decomposition reaction may mean, a double decomposition reaction may mean evolution of a gas. So these are two examples of that. Mark it as read. Now, neutralization reaction. When an acid and a base react with each other, they form salt and water only. This only word is crucial here. So acid has a low pH and base has a high pH, but they neutralize each other and we get neutral solution, which will not change the color of litmus. This will change litmus to red, this will change litmus to blue, but they won't change the color at all. They are neutral. That's why it's called neutralization reaction, which has some applications. But before that, cancel this and remember all these neutralization reactions. Remember, you take any base, react with an acid, you get salt and water only. Base is usually an oxide or a hydroxide of a metal. Exception, ammonium hydroxide. There's no metal here, and yet it is a base. By the way, these bases dissolve in water, so they are called alkalis. That's a special name for them. Now, some applications of neutralization. If a bee stings you, it's painful because of formic acid. So to neutralize the acid, you use a base. You can use slate lime, which is calcium hydroxide, or baking soda, which is sodium bicarbonate. They will neutralize the acid and give you relief. If you have acidity in your stomach, drink a base, like milk of magnesia, magnesium hydroxide, or sodium hydrogen carbonate, which is baking soda. Point number C is cancelled, and point number D says that if the soil is too acidic, add some base to neutralize it. Base like slate lime.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.